As part of this tutorial, we'll complete two separate implementations of using functions. In our first example, we'll create a function to act as a macro, which can be called from anywhere in the code. In the second example, we'll make our code more flexible by using a function to do routing in our video switcher. Once again, let's make sure we're working in the correct source code file. Shut down any editor windows that are open, and then open up the LabMaster source code file. Let's get started. In your code file, scroll down to the button event for our System Power Off button. Our intention here is to move all this code inside the button event into a function so that we can do a complete system shutdown based on several events, but only write the code once and call that block of code from anywhere it's needed, such as a time of day event or an I/O channel event when the room becomes unoccupied. Now that you understand what this function's going to do, let's create the define function statement. Here's a great place to introduce another time-saving tip. Anywhere in the code editor window, right-click. From the pop-up menu, choose Go to Section and choose Define Mutually Exclusive. Your cursor immediately jumps to that section of code. The reason we went here is that all function definitions go just below the Define Mutually Exclusive section under the comments that say Subroutine Function Definitions go below. To create a function, we use the keyword define_function. The style guide tells us that all user-defined functions should use lowercase fn as the first two characters of the name. And, as a general rule, best programming practice dictates that the name of the function be or contain a verb. So, in our case, we'll call this function System Shutdown. We won't be passing in any parameters in this example, but as we mentioned in the previous tutorial, you must still use an empty pair of parentheses. Now, open a set of curly braces to include all the code that will become this function. Scroll back down to the button event so we can move that code into the function. Inside the push handler, I'll highlight all the code and hit Ctrl+C to copy. Now back up to the function definition and paste that code. Here's another quick tip. With the entire block highlighted, you can use the Tab key to indent, or Shift-Tab will allow you to back up an indentation. This function is complete. Now we simply need to make a call to this function. Scroll back down to your button event. Once again, highlight all the code inside the push that's not already commented out. Comment out all the remaining code with Ctrl+B. The last step is to call the function from within the push. To do this, just type in fn. AutoSuggest will populate with the name of our function. Hit Tab to choose our function name. Don't forget to add the parentheses. Compile your code to make sure you didn't make any mistakes. Now that we have this function built, let's really showcase its power. Scroll down to our time of day timeline event. Remember in our timelines lesson, we added a do push to trigger the system off button every night at 10 p.m.? That's really not the best way to accomplish this. Will it work? Yes. However, we don't recommend it. Comment out this line of code, and instead, add the function call. And that's it. We can now call this function from anywhere in the code, just as we did in these two places. Let's move on to another example. This one will be a bit more involved because we're going to learn how to pass values into the function. Scroll up a bit in the code to the Video Switcher button event. More specifically, focus your attention on the sendString statement below case 61. As you probably remember, this case is our take button to send the string to the switcher to make the appropriate routing. I'm sure you can imagine performing a video route on a matrix switcher can occur in a million points in your code. Having to build that string each and every time can be cumbersome. The answer is to create a function that accepts the input and output numbers as parameters. Then, The complicated string only needs to be built one time inside the function. Right-click and go to Section Define Mutually Exclusive again. Just below the other function we just created, let's build a new one. Follow the guideline of using a verb in the function name. Let's call this one fn send to switcher. Now, here's the difference between this and our previous example. Once you open a parentheses, we need to define some variables to hold the values which will be passed in. Since we're just passing in input and output numbers, integer is the best choice for the data type. So type integer and name it nInputNum. Add a comma and do the same for the output number that's going to be passed in. It'll also be an integer called nOutputNum. Make sure you close the parentheses. Next, open a set of curly braces, and just as we did before, go back down to case 61 of the button event and copy and paste that send string into the function. We now need to edit the send string statement to replace the variable names with the variables in the function definition. So, nSelectedInput becomes nInputNum, and nSelectedOutput becomes nOutputNum. Now, we have a working function. Let's compile our code once again. We're still looking good. No errors and no warnings. Finally, scroll back down to the button event and replace the old send string with a call to the function. Comment out the send string. Begin typing the name of the function and select fn send to switcher. Open a set of parentheses and type in the two variable names separated by a comma. Remember, here we're passing in nSelectedInput and nSelectedOutput. That's it. Compile your code and you're done. From now on, if you need to make a route on the video switcher, just call the function and put in whichever input and output number you wish. You now have two great examples of implementing functions. With that, let's get ready for your final exercise. For the last time, you can shut down your LabMaster source code file. We're completely finished with it. We encourage you to use this source code as a reference tool in the future.